welcome to the deep dive. Today, we're diving into something I think a lot of you are really interested in: climate change. We asked you to send in some stuff you've been reading on the topic, and you sent us a ton of excerpts from procon.org. And their big piece is Human Activity Responsible for Climate Change? 13 Pros and Cons.
And you know what's really interesting about this piece? It seems like they last uploaded these excerpts back in 2020.
Yeah, that's right. It's like we're going back in time to 2020 to see what the debate looked like then. So think of this as a history lesson.
Or a time capsule.
Okay, a time capsule into the climate change debate as it stood back in 2020. So one of the things that always comes up is that 97% figure. 97% of scientists agree humans are causing climate change. In fact, it's the first pro argument listed in that procon.org piece. They even mention those peer-reviewed studies and groups like, what is it, the American Medical Association, like big names supporting it. But is it really that simple?
Well, science is rarely ever simple, is it? And you're right, a large majority of climate scientists, they do support the idea that humans are impacting the climate, but even that 97% number has been, debated. Yeah, and it's interesting because in that same set of excerpts from procon.org, there's a counter-argument using a Purdue University survey, also from around 2020, and that one found different levels of agreement, even among climatologists, about whether humans are the main driver of climate change.
Okay, so it's not just as simple as counting heads then.
Exactly. What this difference highlights is just how important the methodology is, how you conduct these surveys, and how you interpret them, especially with something as complicated as climate change. It's not just about who agrees, but how they're asked and what evidence they're looking at.
So maybe that percentage doesn't give us the full picture. So let's look at something a bit more tangible: greenhouse gases. Pro argument 2 in those excerpts, it's all about how human activities, especially burning fossil fuels, but other things too, like agriculture, they're increasing the amount of these gases in the atmosphere. And then there's that whole greenhouse effect, right? How these gases trap heat.
Imagine the Earth wrapped in this giant blanket, right? That's the greenhouse gases. Now imagine humans come along and start cranking up the heat by burning fossil fuels. That blanket, it gets thicker, and the planet starts to get warmer.
And it's not even just carbon dioxide, right? I mean, CO2 gets talked about a lot, but there are other greenhouse gases too, and they're not all the same.
You got it. For example, the source talks about methane. You've got methane coming from things like livestock, natural gas production, and it's like that extra thick, super warm blanket. It traps way more heat than CO2 does, at least over a shorter period.
Right. I remember reading that over 20 years, methane can trap 84 times more heat than CO2. That's insane.
Yeah, 84 times. So understanding those nuances, what each greenhouse gas does, it's super important when we're trying to figure out what impact they're having on the climate.
Okay, so we're pumping out all these greenhouse gases, but the con side, they're still not buying it. They had this argument, con argument 3, I think, where they say that, sometimes in the past, warming happened before increases in CO2.
Mm-hmm.
Not the other way around. How does that work?
It does seem kind of backwards, right? It's like the chicken or the egg with global warming. But it shows us how complicated Earth's climate really is. It's not always a straight line from A to B. There are feedback loops. So, for example, you might have a small amount of warming initially. Maybe that's caused by something like changes in the Earth's orbit around the sun or the sun's activity itself. And then that warming, it can trigger the release of more CO2, which then causes even more warming.
So it's like a snowball effect.
Yeah.
Or a runaway train.
Exactly. It's like this reinforcing cycle. Now, that doesn't mean that the CO2 we're pumping out now isn't a huge problem. I mean, we're seeing CO2 levels skyrocketing at a rate never seen before. And that's definitely driven by human activity.
So it's not just about the CO2 itself, but also how fast it's increasing.
Yeah, and how much of it is coming from us, not natural sources. Which actually, speaking of natural sources, the con side brings up another interesting point: carbon sinks. Things like oceans and forests, which naturally absorb CO2 from the atmosphere. Con argument 4 suggests that maybe these natural processes could be helping us out more than we realize.
Yeah, like the Earth has its own way of cleaning up our mess.
Well, it's like Earth has a built-in air purifier. But the question is, can it keep up? Can those forests and oceans absorb all the extra CO2 we're pumping out, especially as we keep producing more and more? That was a big concern back in 2020. And from what I hear, it still is. It's a huge question. And it kind of gets to the heart of this whole debate. What's the actual impact of all this extra CO2, out there in the real world? And the pro side, they point to a lot of pretty big changes that are already happening, like They list these changes in the procon.org excerpts, and they're connecting them directly to climate change caused by humans.
Yeah, it's kind of scary when you see it all listed out like that.
Yeah.
Temperatures going up, the Arctic ice is like disappearing, sea levels rising.
Yeah.
Even the oceans are becoming more acidic. That can't be good.
No, not at all. It has huge effects on marine life. And those excerpts you sent in, they don't stop there. They also talk about how the oceans are getting warmer again, not great for the critters living in them, and glaciers are melting at a rate we haven't seen in centuries. And rainfall patterns are changing too, like more intense storms, less snow. Oh, and then there's that whole permafrost thing. Remember how we were talking about methane?
Yeah.
Well, melting permafrost releases even more methane, so you get this nasty feedback loop.
Right.
More warming, more melting, more methane, even more warming. It just keeps going.
It's like a domino effect.
Totally. A domino effect, a vicious cycle, however you want to describe it. It's not good. But of course, the folks who aren't so sure about human-caused climate change, they have a different take on all of this.
So if they're not disagreeing with the actual changes that are happening, then what are they saying? It's all just a big coincidence.
Not exactly. Their main argument, which you can see in con argument 2, is that the Earth's climate, well, it's always been changing. They talk about ice ages, they talk about warmer periods throughout history, all happening long before humans were around.
So are they basically saying that this is just like a natural swing of things, like part of a bigger pattern?
That's the gist of it. They're saying what we're seeing now, the higher sea levels, the melting glaciers, the warmer temperatures, it's all part of these natural climate variations that happen over really long periods. Like con argument 8, they focus on sea level rise. They're saying, yeah, it might be happening faster now, but it's been going on for thousands of years. And con argument 11, same thing with glaciers. They've grown and shrunk throughout history naturally.
So basically we have these big changes happening all around us, but the big question mark is it us? Is it natural? Or is it some crazy mix of both? I mean, how do scientists even start to figure that out?
It's the big question, right? It's like trying to solve a giant jigsaw puzzle, but some of the pieces are missing, and we're not even sure what the picture's supposed to look like. It was a question on everyone's mind back in 2020, and it's something scientists are still working on today. And speaking of confusing, the con side, they bring up something else that always seems to come up in these conversations, the sun.
Oh, yeah. I've heard that one. That's not really us causing all this warming. It's just the sun acting up. Is there anything to that?
Well, it's definitely not as simple as some people make it seem, but the sun does play a role in Earth's climate. Con argument 6, it talks about something called solar forcing. Think of it like, I don't know, like the sun has a dimmer switch, and sometimes it gets brighter and sometimes it dims a little. So when it's brighter, the Earth gets a bit warmer, right? But the real question is, how much warmer? And according to, well, NASA is a big one, and a lot of scientific research, the sun's activity alone can't explain the kind of rapid warming we've been seeing, especially since, like, the mid-20th century.
So it's a factor, but not the whole story.
Exactly. It's like, I don't know, trying to bake a cake and then blaming it on the oven light being on. Sure, it gives off a little bit of heat, but it's not what actually bakes the cake. And that actually brings up another point. The con side makes the whole issue with climate models.
Climate models, right? Those computer simulations, scientists use them to try to figure out like what's going to happen with the climate in the future. But I always hear people saying those models are unreliable, that they're making the impact of humans seem way worse than it really is, or that they're just like too simple. You know, the climate's so complicated, how can a computer model actually predict anything?
Yeah, it's a common critique, and con argument 10, it gets into that. And it is true that models have limitations, just like any tool we use in science. I mean, think about it. We're trying to represent something as complex as the entire Earth's climate and all the things that can influence it on a computer. It's incredibly difficult. So yeah, there are always going to be uncertainties. But the thing is, those models are constantly being refined, improved, updated as we learn more about how the climate works and as we get more data.
So like they're getting smarter all the time.
Exactly. The models they're using today are so much more sophisticated than even just 10 years ago. Although, con argument 10, it also brings up something else that's important to consider. Observational data. What's actually happening in the real world, right? Like things we can measure directly. Some scientists argue we should be paying even more attention to that observational data, not just relying on what the models are telling us. It's about finding that balance.
Yeah, that makes sense. It's like, I mean, if I'm planning a picnic, yeah, I'll check a weather app on my phone, but I'm also going to look out the window to see what it actually looks like outside.
Exactly. So you need both the models, those projections into the future, and the real-time observations to get the full picture. But don't get me wrong, those models are still super important. They're essential tools for climate scientists. They can use them to test out different scenarios, see how things might play out if we do this or that, and ultimately, hopefully, make better decisions about the future.
So, okay, we've covered a lot of ground here. The whole 97% consensus thing, the greenhouse gases, the actual changes that are happening on Earth, some of the counter arguments. If we had to sum up, like, what was the state of the climate change debate back in 2020 based on what we've read?
Well, I think it's safe to say that the scientific evidence pointing toward a significant human influence on climate change, it was already pretty compelling back then. But, and this is a big but, there were and still are some really important questions and uncertainties about, how complex the climate system is and how much of what we're seeing is natural variation versus human cause.
It's a lot to take in, that's for sure. But it sounds like regardless of whether we're causing all of it, we're definitely not making things better.
That's for sure. And that actually reminds me of something else from the Did You Know facts at the end of those procon.org excerpts. They mention that the U.S., even though it only makes up about 4% of the global population, historically, it's been responsible for almost a third of all greenhouse gas emissions.
Wait, a third? Seriously?
Yeah, it's a lot, which really makes you think about, the responsibility that developed nations have when it comes to tackling climate change. I mean, they've contributed so much to the problem historically.
Yeah, there's a lot to unpack there. Well, I think this has definitely given us all a lot to think about. It's a complicated issue, but this whole deep dive going back to 2020, it's really helped to understand where things stood then and how we got to where we are now.
Totally. And remember, science is always evolving. We're learning new things all the time. So what we understand about climate change, that's going to keep changing too. It's important to stay informed.
Absolutely. Well, on that note, thanks for joining me for this deep dive. Until next time.
Anytime.